So today we're going to be doing transformation of exponential equations. Now, the same rule apply to transformations of exponentials as with any other functions on any other graph. We know that the number out front, a, which is our starting value, if we have large values of a, which means a is greater than 1, that's going to be a stretch. It's going to increase the height of our starting value and take our graph and stretch it. So this is going to be a stretch or increase our start value. If I have a is between, so actually let me put, that's going to turn into a 0. If a is in between 0 and 1, we're going to call this a compress. And so if a is between 0 and 1, like a fraction or a decimal, it's going to take our graph and it's going to take that nice little curve that we had and it's going to squish it into a relatively flat curve. So this is going to decrease our start val. And finally, if the a is a negative, it's going to flip it. So a negative a is going to approach our asymptote from the bottom, regardless of which way it actually approaches, as opposed to a positive a, which approaches it from the top. So again, we're not concerned with which way the graph's going, but where it is in relation to our asymptote. With our h, we know this is an inverse relation because of that minus sign. We know that if we add an h, we are going to be moving to the left. If we subtract an h, we're going to be moving to the right. And mostly we're going to be using this as fitting our graphs. Same as with plus k. Now k is plus, so it's a direct relationship, which means plus k is going to move the graph up, minus k is going to move the graph down. Also, we're going to call this a flip. Awesome. So let's go ahead and take this theoretical equation, y equals 2 times 1/3 to the power of x, and we're going to move it up by 5. That's going to be a plus k. So we have y equals 2 to the 1/3 x plus 5. If we wanted to move it down, it would be y equals 2 to the 1/3 power of x minus 5. Oh, minus 6. Moving it down 6, I tried to move it back down 5. Awesome. So the left 4, this is going to be the h, so it's connected to the x. So we're going to take our y equals 2 to the 1/3 to the power of x, and this is going to be left, so an inverse relationship, so plus 4. Likewise, if we tried to move it to the right, 2 to the 1/3 x, right is going to be minus 7. And if I wanted to stretch that, I'm going to say stretching means a is bigger than 1. If I stretch it by 2, I'm going to multiply that starting value times 2. So 2 by 2 is going to give me a 4. Times 1/3 x. If stretching is multiplication, compressing must mean division. So y equals 2 divided by 4, and 2/4 is 1/2. 1/3 x. And so the last part of what we're going to be doing is we're going to be doing each of the transformations above combined and reflecting across the axis. Okay, cool. So this requires us to do every little piece. We're going to move it up 5 and down 6. We're going to move it left 4, right 7. We're going to stretch it and then compress it. So why don't you go ahead and pause the video real quick and give this a shot and see if you can knock it out. Okay, so first off, what we know is I know that I'm going to have to reflect it across the x-axis, which means it's going to go from above to below, which means I'm going to have to change the sign on that a. So I know first off, I'm going to have to go ahead and pop a negative sign right out front. Secondly, I know I'm going to take that 2, and I'm going to multiply by 2. So 2 times 2 is 4. And then I'm going to compress it. So 4 divided by 4 is going to give me a 1. So I have a new value of 1 sitting right there. Times 1/3 raised to the x, okay? So my x in this case, I'm moving it to the left 4, so I add 4. Right 7, so I subtract 7. So plus 4 minus 7 is going to be minus 3. The last piece is I'm going to move it up 5 and then back down 6. So plus 5 minus 6 is going to be minus 1. So let's take a look at what the end result was. So if I look at my graph and I read it, I know that it was positive, it's negative. I know 1, I flipped. 2, I went from a 2 to a 1. So that must mean that I divided by 2. So I compress by 2 was the end result. X minus 3, this is a negative relationship. So that means that's going to be a right 3 motion. And minus 1 is a direct relationship, so that is going to be a down 1. Awesome. So why don't you go ahead and try this next one, knock out all the individual pieces, unpause the video when you're done, and see how well you did. Okay. So I know with these first two, it's going to be pretty straightforward. I'm going to have a y equals starting value of 3 multiplied by 5/3 x up 9. For down, I'm going to say y equals 3 times 5/3 x minus 4. Left 17. That's a really big shift left. This is going to be way up in my exponent. And because it's an inverse relationship, left 17, I normally think minus, but inverse it, change it to a plus 17. For right, normally which would be a plus, I'm going to inverse it and say minus 11. For my stretch 9, that's going to be 3 times 9, which is going to give me a value of 27. And for my compressed 3, well, that's going to be 3 divided by 3, which is going to give me a starting value of 1. And if I wanted to do all the above transformations combined and flip it across the x-axis, well, I know I've got a couple things going on here. I know I'm going to have a negative sign out front, which is going to be the flip. I know my 3 stretch 9, so 27. Compress, so divide by 3. That's going to be an ending value of 9. 3 times 3, divide by 3. Or 3 times 9, divide by 3. Apologies. Plus 17 minus 11. That's going to be an end result of plus 6, which is a leftward motion. And then I'm going to add 9, take away 4 for an end result of add 5. And if I go down my list, my first thing I notice is that 1, I flipped it, reflected it across the axis. The second thing I did was my 3 became 9, which means I stretched it. The third thing I did was I have a plus 6, which means that I moved it left 6. And last but not least, that plus 5 at the very end means I moved up by 5 from the start to the end. A lot happened in the middle, but this is where we are. And there you go.